Okay, guys, welcome back. We are going to start off. We're going to be doing some paper six revisions today, guys, because the 10B boys here, they're actually having an exam soon for paper six, which I think should be quite easy. But it's a good chance to describe how this whole thing works, guys. For paper six, it is absolutely crucial that you. Oh, oh, your mock is tomorrow. Great, just in time then. It is absolutely crucial that you actually have been doing some past year papers, guys. In general rule, you need to know that this paper consists of 40 marks, and if you did everything correctly, guys, you are actually supposed to score no less than 30 marks for your paper six. It's quite standard in a way that it's always going to be like measuring some stuff, what's the precautions, what are the units that you should be following. Then this one here, I'll go into this later on as well because I see this come up very often now. Right, then there's going to be more measurements, follow the formula, write everything down, what are the precautions, and so on and so on, right? And this graph here also I have to go through it as well because this one here consists of 4 marks. We'll go through this one here, right? When I say paper six is easy, the reason why I say paper six is easy is simply because the questions are quite repetitive. So in order to study for your paper six, right, what I would recommend you doing is you open up your paper six questions on one side of your table, right? Then you open up the mark scheme on the other side. Straight away, as soon as you're doing like how you do paper four, as soon as you're done with one question, you straight away look at the mark scheme and you analyze what you did or what you did not do right or wrong according to what you have written out, right? And then usually it will be quite straightforward. But for the paper six experiment question, which consists 7 marks here, there's going to be like some tricks to it, right? First and foremost, the most simple trick is that number one, each bulletin point here that you see here is actually going to consist of at least 1 mark, guys. Right, each bulletin point is going to consist of at least 1 mark. So what you have to do is when you write your experiment, you actually need to checklist this one by one and explain all the things properly. Like for example, this one here, what do they want? A student investigates springs. Springs are made from different metals. Plan an experiment to investigate the extension of a spring made from different metals. So from here, the keyword here is because it has different metals, right? So different metals will form different springs with different spring constant. The general rule of thumb is you definitely need to memorize the formula, right? In this scenario here, it will be like F equals to Kx, right? It will be F equals to Kx. It will be like F equals to Kx. And straight away, when I see that there is different metals here, I know for a fact that, oh, this is definitely going to be a different spring constants, right? So each and every one of them are going to extend differently. By how much, you do not need to know. In general, when you do these kind of questions, a lot of students, they always try to try to be extra smart and they try to tell me what's going to be the results. But in reality, you are not even expected to know the results. You are expected to write a simple step-by-step guide that any idiot reading your description is able to conduct this experiment, right? So the general idea you should have in your head is that when you're doing all these experiment questions, you are an author, right? To write this experiment, any idiot that reads this step-by-step guide is able to do the experiment. So you should keep that in mind when you're writing down some stuff, right? Then from here, they give you these kind of apparatus, balls, clamp, stand, meter, ruler, spring made from different. Oh, this is already made already, so you don't have to do it. Right, selection of loads with hanger. Obviously, if I see that the springs are already made and I see there is a selection of loads with hangers, then obviously I'm supposed to load different loads onto the spring and see how much it extends, right? Because you're supposed to investigate the extension of the spring made from different metals, right? So from here, most likely, looking at this scenario here, I'm most likely supposed to find the spring constant, which is the F over X, which is in newtons per meters here, right? Most likely, right? So if I look at this question here, you can also use other apparatus and materials usually available in school laboratories. In your plan, you should write a list of suitable metals for your spring. Now, this is the first tip, guys. In these kind of questions, right, when they ask you to write suitable metals or use suitable lengths or use suitable weights or whatever, right, the general rule of thumb is at least you must have 5 different things, right? For this scenario here, you have to die lah, right? 5 different metals are aluminium, steel, cobalt, copper, or and one more whatever random metal that you can think about lah, right? That is usually a general rule of thumb, especially when it comes to these kind of experiment questions. Okay, so this is number 1. Okay, I need 5 things. Draw a diagram to set up the apparatus that you set up you would use. So they are essentially testing your drawing skills here as well. You don't have to draw anything too fancy lah, right? But when they ask you to draw a diagram, the one tip that you must know is you must definitely label each and every one of the things, because like I said, right, you're writing a manual for any idiot to read, right? And if I look at this manual and I don't see any labels, then I don't know what I'm not a physics student. I don't know what this is. You better label every one of it so that I can literally blindly follow your guide and do this experiment, right? So then briefly explain how you could carry out this investigation. Usually to my experience, briefly explaining this investigation will either be 1 to 3 points depending on the bulletin points that they give you here. But if I look at the bulletin points here, there's like 1, 2, 3, 4, 5, 6 bulletin points, right? Then I know that this one here is actually going to carry 1 mark only. If there is like less bulletin points, then briefly explaining the investigation should be anywhere from 1 mark to 3 marks. But because there's already 6 bulletin points, right? Takan, they're going to give you like 3 marks for this one thing, it doesn't make sense. So it's important to actually analyze what information you have and like roughly think like each and every one of the bulletin points, how many marks is it going to give you already, right? Then state key variables. This one here, which the students, they will always get it wrong. You see this word variables with an S, right? It means to say, most of the time, right, you need to write 2 constant variables. In fact, in the mark scheme, right, they will even say that if you only write 1 variable, you will not be awarded your mark. If you write 2 variables, because it's variables, right, then only then you will be rewarded your mark. So keyword here is you need at least 2 constant variables. Then draw a table or tables with Coulomb headings, very important. You must draw the Coulomb headings with the appropriate units. So whatever that you have recorded, like for example, this scenario here, you're recording the force and the extension, right? The extension here. Make sure you bloody write the units, guys, because if you do not write the units in here, for sure, you are going to lose your marks. And then don't try to be extra smart about this. What I would recommend you do is do not write any of the information here. Some students, they're very pandai and they tell me like, okay maybe force you can write because you are supposed to use different forces, right? 5 newtons, 10 newtons, 15 newtons, 20 newtons, and 25 newtons. Oh, maybe that's the reason why you don't need 5 materials here. The forces, like I said, guys, the general rule is if you're uncertain, you need at least 5 measurements. 5 measurements or 5 springs. But in this scenario here, if I look at it, more likely, after reading this statement here, right, more likely is you only need 3 materials, only a minimum of 3 materials, right? But you will need a minimum of 5 different forces here. And you need to label and write down that you have 5 different forces here to show the examiners that, oh, this guy actually knows what he's doing, because with more data, they will give you more information and you'll get an average of everything else, right? So forget what I said about this one here. After reading this statement here, right, then now obviously you don't need 5 materials, because if you have 5 materials and 5 different ways, the table will be too damn long, right? So in this scenario here, you only most likely need 3 metals, as I can see from the mark scheme here. They actually just write 3 different metals. At least you can write 5 right? It doesn't matter, but you need a minimum of 3. But looking at the scenario here right now, I will most likely write 5 different ways instead, because the general rule is 5 is the golden number for your experiment questions, all right? Then you are not required to enter any readings in the data, obviously. I hope everyone knows this by now, right? So make sure you know this. Then explain how you would use the reading to reach a conclusion. Guys, if you see this statement here, I always see students, they try to be a bit too funny with the conclusions, guys. The question is not asking for you to tell a conclusion, you are not, the question is not saying like, what's the conclusion for this experiment? You don't need to do that. You need to, however, explain how you would use the readings to reach a conclusion. And it's a damn standard answer when it comes to these kind of questions here. Most likely, you will be comparing the force and the extension, or the extension and the material of the spring, right? Depending on what you want to compare in this scenario, most likely it's going to be extension versus the material of the spring lah. So for me, right, if I want to make it very simple, I'll just say that by comparing the extension versus the different materials of the spring, a conclusion can be drawn. And bam, I'm done already. I don't know what the conclusion is. I don't know what iron, how much iron is going to extend, how much steel is going to extend. I don't know, because you're not supposed to know. You are supposed to write a guideline for any idiot to read through this statement and then tell you the final results for this experiment here. A lot of students, they always get this wrong, and of course, if I look at this one here, there's only 6 bulletin points. So some of the students will be asking me, hey, then how am I going to get the 7 mark? Most of the time, the 7 mark or even the 6 mark could be a hidden mark. Usually, the hidden mark will be something like repeat the experiment 3 times, make sure that you have at least 5 different forces used, make sure that you have you have the units on your tables or something along the lines, right? So if I analyze this mark scheme here, right? If I analyze this mark scheme here, look at the first step, diagram. Okay, your diagram is going to give you 1 mark, right? At least 3 different methods, like I mentioned just now, at least going to be 1 more mark. Method that you're going to briefly explain the experiment, this is going to be 1 mark. And this is where you get your hidden mark, right? In this question here, then obviously the hidden mark is going to be by repeating the experiment now. And most of the time, by simply stating, repeat the experiment 3 times to get an average reading, right? Bam, you'll get your hidden mark already, which is your 7 mark. Then everything else is in the bulletin point already. Key variables, 1 from blah, blah, blah. Oh, key variables, you need 2 of it at least. Original length of the spring, diameter of the spring, number of turns, or original length of the wire or spring, whatever. You need 2, then you get your 1 mark, right? The table with coulombs for metals of extension and length, right? This is your other mark. Most likely you'll need your correct units as well, right? Like I mentioned just now, you need this 1 mark here. And finally, compare the extension for the fixed load for each spring. By comparing this spring with a different metal, a conclusion can be drawn. This one here is the most standard answer that you can see in your experiment question. And the second one that I see a lot in the mark schema is plot or graph of extension versus load and compare each and every one of the spring. This one also is a damn standard answer for your conclusion. You'll notice, guys, none of the answers here is going to tell you which bloody metal is going to extend more or extend less, guys. Very, very, very important. Don't do that. I see a lot of students, they always tell me that, oh, in conclusion, this metal is going to extend more than metal because it has a higher spring constant. Who knows? You know. I don't know. I sure as hell don't know. So how are we supposed to know? You don't know also, right? You are only supposed to teach them how to reach the conclusion. Okay, everyone. Anyone's got any question or not for this part here? Good. If you have no questions, right, guys, I want each and every one of you guys here to write down this and send me your answer. I want to read through and give you and see whether you wrote everything down correctly or not. Guys, you have 10 minutes to write everything down and then send your answer to me right now. You can write it on a piece of paper. You can type it into the group chat. You can type it into the Zoom chat, preferably the Zoom chat, right? Or I actually preferably write it on a piece of paper because you'll be needed to draw the tables and the graphs if needed. So guys, everyone, you have 10 minutes or less to do this question here. I want to see your answers. Do it right now. it's not here. Oh, Anna. Where did Anna go? Oh, it's not here. Oh, where's Joe? Wait, Joe not joining us today. Bullet point can, but yeah, actually they don't really penalize you for writing an essay or bulletin point but I must say that bulletin points is much easier to read Send me your answers, guys, once you're done. You need 5 forces, Jen Lim. Where's the last one? You have 5. Oh, one more thing, guys. I want to mention about the force part, guys. For the force, right? Don't use don't use things like 1 Newton, 2 Newton, 3 Newton, 4 Newton, and 5 Newton. You need a minimum of at least 5 Newtons difference. Right? Yeah, so 5 Newtons difference and then like 5 different forces lah. Right. So you can use like 5, 10, 15, 20, and 25. You need 5 different forces. Right. Metal spring. Oh. Iron, steel, aluminium, cobalt, and copper. Okay. Wow. Janim, I must say your handwriting is ugly as shit, man. I can't read nothing. Wait, use same something if metal for spring. What the? I actually gonna read this. Set up the boss clamp something stand at the what spring, then attach the holy shit. I actually cannot. Hey, the hell. Oh, why need different forces? Because you need different forces to test. No, you need different forces to test out the spring constant, right? For example, in this scenario, you're most likely going to draw the Hooke's law graph, right? You need more data to draw it all the way upwards, You get what I mean, no? So in general rule, you need 5 measurements when you're doing the experiment. Record result and see which expands the most the experiment. Repeat the experiment 2 to 3 times. That's it, man. So, what's your conclusion, Jian Lim? And then, what's the constant variable here? Set up the constant spring, attach the spring rate, then attach the time rate. Use same length of metal. Oh, this is your constant variable. Weight use same length of the spring. I don't think the weight. I don't think the weight plays a role, right, for your key variable here. Obviously, you're supposed to use the 5 different weights for the 5 different stuff, right? Well, your control variable is not the weight. The weight is your measured variable or some other variable, right? You should say either use the same length of metals or they have the same diameter in terms of their cross-sectional area, Jian Lim. This is like, yeah. Your key variable there, change your weight into same cross-sectional area. Do the same and give me your conclusion. Where is your conclusion? Well, you guys never do paper 6 before one, in school. Nani? Jesus. What do you mean, why need force? You need the force to hang the spring, right? To extend it. What do you mean? So you just want to extend my measure extension. Oh?
Actually, I don't think need different force because they wanna measure the extension from the different metal only. And then I don't think need different forces,
You need different ways to have different extensions, right?
No. They want the same force and then like same force to like test the different material of the metal. I searched the marking scheme. Oops, sorry. No need different force. I mean, I don't think need lah.
Let me see. A student investigates springs made from different metals. An experiment investigates the extension of the spring made from different metals. But you will need different forces to get a more precise spring constant, though. No. Okay, fine, you can write it your way, but it does. You know what I'm trying to say, right? You'll need like different forces, right, to get the different extension of the spring. Yeah, I mean, arguably in this scenario, maybe you don't need because of this statement here, but if you want to find the spring constant, for sure you'll need different forces to find the spring constant, right? So in reality, this question here is actually testing your understanding to find the spring constant, which is your F over X, which you will need different forces here, right? Different forces here to find different extensions. But there's no okay. I want to clarify one thing also. For these kind of experiment questions, right? There's literally every way to do it. There's not only one method to do it, like how you do your parallel and series circuits, right? There's always more than one way to do it. As long as you are able to hit all of these things here, it's also fine. But it also depends on how you are going to structure your answer also. So if let's say you insist of not using the force, yes, you can do that. But let's see how you structure it. Do we need to draw a graph? Well, yeah. If let's say, for example, your conclusion is by comparing the extension versus the different metals, yeah, then maybe you'll need a graph. Yeah, but it's not necessary. Once again, you can write, like for example, by comparing blah 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 versus blah blah blah, a conclusion can be drawn. Wait, no one else sent me an answer. It's kind of really shit. Yeah. Mm-hmm. Oh, actually, the table here, I think you draw like a force extension, then you're going to label like different metals with different gradients here instead. Now that I think about it, to indicate that it has different spring constants. Okay, everyone. Anyone else wants me to check your answer? Kunling has just given me your answer. Yeah. Wow. Suitable metals for spring iron copper. I don't know copper steel. Attach a hanger to the stand and that is firmly attached to the ground. On the hanger, mango one at the spring. Okay, you should attach another hanger on the opposite side of the string and maintain mango on the second hanger. On the second hanger is where you will attach your different nodes, measure your spring extension, and record it on the graph. Using different weights or different loads, you can measure the extension and measure it onto your graph. Repeat the experiment with every metal and load. Repeat the whole experiment 3 times to obtain an average reading variable constant. Hey, you don't need the independent. Oh, this is one more scenario which I want to talk about, guys. A lot of you guys, you always like to write, for some reason, the constant variable, the independent variable, and the dependent variable. You do not need that, guys. You only need to tell me 2 constant variables to make this experiment like fair, right? So that it doesn't like affect the other variables as well. You don't need the independent and dependent. I don't know why the school teachers may teach you differently. I've seen this a lot in different schools as well. Just write 2 constant variables. Using the average results gained from an experiment, you are able to you're able to come to a conclusion using the results from the experiment, or you could using the results from the experiment, you are able to come to a conclusion by comparing the extension versus the different metals. Then done. Comparing the metals. Conclusion as to which metal extends the most. Yeah. Couldn't you heard what I said, right? For your conclusion, you understand what I'm talking about?
Yeah.
Oh, you have the book. Wait, let me read the house one first. Suitable metals, copper, iron, aluminium, constant variables, length of the metal wire, and distance from the ground. Distance from the ground. But if you have a constant metal, wait, you know, if you have like a constant, you have a constant length for the metal springs, then shouldn't all of them have the same distance from the ground? So this is like the same thing written twice. So I think for you, you better write like same cross-sectional area for each and every one of the metals. That will be better. Measure the initial distance of the spring from the ground and the final distance of the string. Okay, for your briefly explain how to carry out the experiment part, right, Junhao? Can you say like at least start off with the diagram, the apparatus as the above diagram is set up. First, you put on the loaded weight of 5 newtons and extend and measure the extension. Then do it continuously for 5, 10, 15, 20, and 25. Record all the data down onto the table as shown. And after that, extension. Yeah, your briefly explain how to carry out the experiment is too brief, Junhao. Write a little bit more detail. State that you're supposed to record the information down onto the table with the different weights. Extension with 5 Newton compare. And then where's your repeat the experiment? No repeat the experiment. How to get your 7th mark? Junhao, compare the extension with the force of 5 newtons to find the spring constant of each method. Okay, your conclusion is acceptable. Your one, you won't get the full marks, I will say. Your constant variable there already lose 1 mark already. And what to change? Give me 2 constant variables, and then your conclusion. Your conclusion there also looks a bit weird. Change your conclusion by comparing blah 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 versus blah blah blah. A conclusion can be drawn, or by plotting a graph of blah 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 versus blah blah blah. A conclusion can be drawn. Something like that. Okay, let me read Scott's answer. Hold on. You also the same thing, Scott. Independent variable, constant variable, dependent variable. All no need. Give me 2 constant variables and can release Scott. After that, okay, set up the experiment. Set up the experiment as shown in the diagram. An additional tool that will be needed is a meter ruler to measure the extension. Hang the spring by the hanger, hang the load near the bottom end of the spring. Identify the extent length by measuring using meter ruler. What results and data should be recorded? Newton's spring material 1. Wait, didn't I tell you that you need at least three spring materials, Scott? You need 3 of it, so you need to extend 1 more box out. Experiment should be repeated at least 3 times for the reliability of the results. Okay, in conclusion, F equals Kx. Scott, this is exactly what I tell you not to do for the conclusion. You don't know the answer, right? You need to say how to find the conclusion. And in this scenario here, by comparing the load versus the extension of different springs, right, a conclusion may be drawn. That's what I'm talking about, Scott. Okay. So someone messaged me here. Oh, Shami messaged me on Zoom chat. This of metal used is iron, aluminium, zinc, constant variable, length of the. Shami, you're there, right? I'm reading yours right now. constant length of the spring, diameter of wire, same size of metal, step to experiment, measure and record initial length of the spring. Okay, add the first load of 5 and measure extension of spring, continue and measure extension of spring. Do the same for the other metals and record the results. Repeat experiment 3 times to find average. Above conclusion, compare the extension for each load for each metal. Okay, yeah, this is good, but I can't see your table and your diagram, so I can only assume you did it correct. Lazy your head, bush. Okay, Shermin's answer is quite good, I would say. You should attach another. Wait, let me read your answer right now. You should attach another hanger on the one on the second hanger is where you attach a different loads, measure spring extension, same spring length and same cross-sectional area. Using the average result gained from the experiment, you are able to come to a conclusion by comparing extension of different metals under different loads. Okay, good. Yeah, I think you hit everything right now. Let me just double check. Oh wait, you repeat the experiment 3 times? Oh, okay. Yeah. Let me just double check. Yeah. Yeah, I think you'll get 2 marks right now. Okay. Wait, Tavish, let me read your answer. Wait. Oh, it's in PDF. Everyone can read your answer then. Oh, very nice. Let's see. 6 tree springs are made of iron, copper, and nickel with the same length. Okay, set up the apparatus as above. Then start the experiment with metal 1. Measure the initial length of the spring well and mass. Then add loads and measure the length of the extension using a ruler. Okay, key variables are the length of the spring and number of coils of the spring. Repeat the experiment at least twice or thrice to ensure blah blah blah. Metal 1, copper. Wait, how come you got only 3 metals here, but you got 5 metals here? Nani? It's not tally, Tavish. Right, if you wrote 3 here only, then you can only write 3 here, ma. Right. Okay. And after that, okay. Conclusion. Heaviest load. Lightest load. No, this is not heaviest load and lightest load. This is like metal 1 and metal 2 and metal 3. Compare the graph, and the heaviest load will eventually have the steepest. No, this one here is like the highest spring constant will have the highest gradient. Then you, but okay, let me just change one thing here. You just say like by plotting for your conclusion, Tavish, for your conclusion, right? You say like by comparing the load and extension of different metals, a conclusion can be drawn. I repeat now, by comparing the load and extension of different metals and plotting it onto a graph, a conclusion can be drawn. You hear what I say? Wait, you hear what I say? But yeah, I think everything else is okay. Yes, it is. It's keyword. Okay, who else I haven't read yet? Jay, wow, can flip the page and send it back again or not? Jay, very hard to see. I need to tilt my head. Set like tilt the image, then send it back to me. Okay, good. Wow, now it's very small. I cannot see it. I actually cannot see it. You need to go closer. I cannot see it. Nice keyboard, by the way. Zoom close, I cannot see the words that it's too small already right now. Oh, Tavish, you want me to repeat? Let me just type it here. Okay, much better. The list of suitable materials for the spring will be iron, copper, steel, bronze, and brass. Measure the initial length of the spring and add the load, and then add the load to the end of the string. Measure the string after adding the load and record both lengths. Repeat this experiment with the spring of different materials. The variables to be kept constant are the initial length of each spring and the diameter of the wire. The spring that has the largest difference initial length and what has the larger extension? What? Hey, where's my repeat the experiment? Jerry, where's repeating the experiment? Where's the units for the table? 2 points gone. Repeat the experiment and your units for the table. And then your conclusion, the spring that has the largest difference initial length and the final length has larger extension. You don't know that. I don't know that. You're not supposed to know the conclusion. This sounds like a conclusion to me, but you need to tell them how to get the conclusion. And thus, you must say by comparing the final extension versus the different materials of the spring, a conclusion can be drawn. Namo. Junhao, can you check my new answer here? Compare the extension with the force of 5 newtons to find the spring constant of the repeat the experiment 3 times. Measure the length of the unstretched spring and measure the length of the spring. Plot the results on the table given. Is this your conclusion, Junhao? Yeah, this is better. Yeah, this is better. Compare the extension of find extension from. Wait a minute. Where is the conclusion? Where's your conclusion, Junhao?
It's the compare the extension one.
Compare the extension with the force.
Wait, that's the old one. You write new one.
Repeat what? After you write the conclusion, only you say repeat the experiment. Write your repeat the experiment before the conclusion. Okay, Junhao, for your conclusion, all right, let me restructure it for you, okay? Let me just type it up here right now. By comparing the extension versus the different types of the method. Conclusion can be done. Once again, you don't have this is I think this will be better. It sounds more like how to find the conclusion. Yeah. Okay, everyone, I have given you the pointers for each and every one of your answers already, guys. I just want to highlight one more thing, which you will see most likely happen in your paper 6, guys. Guys, I want to talk about this graph here, guys. This graph here is very, very important. You must score well for this graph here because it's 4 marks, guys. And I'll tell you exactly where the 4 marks are, okay? The first mark is by labeling the axis with the proper units. For example, V and L in cm and voltage, right? This is your first mark. The second one is by plotting the proper points into, from this original table here, right? That is your second mark. Your third mark, guys, your third mark is obviously using the suitable scales, guys. Sorry, this should be your second mark, guys. For example, if in this scenario here, this is your x-axis, right? And this is your x-axis, and this is your y-axis, right? So if I know that how many boxes here, I separate into 5, 10, 15, 20, 25, 30, 35, and 40, right? The general rule for you guys to draw a graph is that you must use at least 70% of the graph, guys. You need to use at least 70% of the graph, meaning to say, if you drew a graph like this, right? You drew it like this, right? Which is just barely using 30% of the graph. You are absolutely wrong, You will not get your marks, guys. So if I see here, it's like 30 old boxes and there's only like 1.9, maybe each one is just like, I don't know, 0.2, 0.4, 0.6, 0.8, then 1, then 1.2, 1.4, 1.6, 1.8. Yeah, most likely this is going to be the scale, but do your own make your own judgment, guys. It looks to me that this is going to be the scale. Every box is 0.2. And if 0.2 doesn't work, don't go for 0.3, guys. Each and every one of the scales must be an even number. Don't go and write 0.3, right? Unless it's 0.5. Yeah, I think you can use 0.5, depending on the situation as well. But in general, use the 70% of the graph. And from here, obviously, it's going to be like 20, 40, 60, 80, and 100, right? You need to use at least 70% of it. And the final mark, which is the most important one of them all, the students, they will always ask me this question here. They'll say that, teacher, based on the answer that I have, it seems like I'm going to draw a curved graph. Should I draw a curved graph or should I draw a straight line graph? And my answer to everyone is the same. It doesn't even matter, guys. They don't care whether you're drawing a curved graph or a straight graph. Usually the mark scheme doesn't even mention which kind of graph it is. However, the mark scheme will forever mention that it should be a good line of judgment which should be thin and continuous. What do I mean thin and continuous? Let's say, for example, if you drew a graph like this, and I say, hey, shit, got stunned a little bit, then you draw like this. This one here, straight away, you lose all your marks, guys. You lose the 4th mark, right? Because you need to be a thin and continuous line. And the best line of judgment is the same like what you do in mathematics. Let's say, for example, I have a graph that looks something like this. Okay, let's say I have like a line like this, right? You can draw a graph that is going to go somewhere like this here. Oh shit. You can draw something like this here. Okay, you can actually draw something like this. Why? Because it's always going to be the +1 rule. What is a +1 rule? Each side of the graph that you see cannot have more than +1. For example, in this scenario here, there's only one point that hits the line, right? Okay, good. This one don't care already. On the left side of the graph, there are 2 points. On the right side of the graph, there are 2 points. This is a +0 scenario. it is acceptable. Even if let's say there is 3 points on the left and there's 2 points on the left, this is merely a +1 graph only, right? If it's a +1 graph, then it's fine. But once you have 4 points here, which is a +2, guys, +2 difference between the two sides, this one will not be considered a best fit graph already. If let's say you have 4 points here, the minimum amount of points here you must have is 3. You can have up to 4, and you can even have 5 here. It's fine. But once you have 6 here, then once again here is 4 and here is 6, right? It's a +2 difference already, right? Then it cannot work anymore, guys. When you're finding the line of best fit, or the what's it called, the line of the best fit graph, what's it called again? The best fit graph, or whatever graph it's called, right? Make sure it is only +1 difference on each and every one of the sides. And it doesn't matter if it's a straight line or a curved line, as long as it is a thin continuous line, it will be acceptable. And as you can see from once again the mark scheme here, the axes are labeled correctly, like what I mentioned just now. A suitable scale, meaning to say you need at least 70% of it. All plots are correctly plotted. I mean, this is the bare minimum you can do, right? But if you follow this, you cannot do, man. And a good line of judgment, it must be thin and continuous line. If you get this one, all this right, then bang, easy for marks. Oh, be careful with all this table as well for those who are going for a paper 6 tomorrow or this week. Usually in paper 6, they love to like leave one part empty and they'll expect you to write the units. So as soon as you see the table, a good habit is to straight away check and see if the units are there or not. If the units are there, then fine, you can just proceed on. If the units are not there, then you better write down the units yourself, guys. This is very, 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 very important. Okay, one more thing I do want to highlight is going to be, it's going to be this one. Maybe this one. It is within the limit of proportionality on. I think it's this one. Yeah, this one here. Okay. For those who have been doing some paper 6 questions, they'll ask you, maybe this is not a good example. Let me find another question. Wait. They'll ask you to compare 2 things and ask you if they are the same thing or not. Wait, let me try to find those kind of questions. This one here. This one here. This one here. This kind of question, guys. Are you looking at my screen? Yeah, everyone look at my screen here. These kind of questions always comes up in your exam one, especially paper 6. This is like literally 3 marks every year, guys. They'll ask you to state whether this compared to this is the same as this or not, and your answer will always be either yes or no. And depending on whether it's yes or no, right, your answer will be yes, because the difference is very small. It is within the limit of proportionality or limit of experimental accuracy. Or number 2, you say that no, it is not acceptable. Why? Because the difference is too large. It has exceeded the limit of experimental accuracy. Let me type this down. It will either be yes, the difference is small, it is within the limit of experimental accuracy, or no, the difference is too big, it has exceeded the limit of experimental accuracy. This one here is damn 3 marks, guys. You must know how to answer this question. Usually they'll ask you to compare 2 things one. And in general, if they are within a 5 to 10% difference, it is definitely acceptable. For example, they say that, okay, right now my theoretical answer is like 100 degrees Celsius, right? And then when I do the experiment in the lab, I find out that, oh, the actual answer is like 98 degrees Celsius. Then they'll ask you briefly explain whether these 2 are going to be the same or not. then obviously look at the small difference, then yes, lor, the difference is very small. It is within the experimental limit of accuracy. Unless, right, you theoretically, you calculate the temperature to be 100 degrees Celsius. Then when you do the experiment, right, hey, something went wrong. It went to 70 degrees Celsius instead. Then obviously the difference is too large, lor. If the difference is too large, then your statement is no, it is not the same. Why? Because the difference is too large. It has exceeded the limit of experimental accuracy. This one is damn standard in the terms of the question. Is a damn standard way to get 3 marks. Okay, everyone. Anyone don't understand what I'm talking about? Anyone wants me to repeat anything that I've mentioned so far? One last thing before I end the day, guys, which is going to be these graphs here. Okay, here. This one here. Hey, if you see this kind of diagrams in your exam, right, which comes out a lot, by the way, for those who have actually been doing some paper 6, most of the time, right, they'll give you like pin 3 and pin 4. Then they will ask you to draw pin 1 and pin 2. So most likely this scenario here is going to be like either a refraction or diffraction scenario, right? Most likely refraction. Yeah, I recorded this class. I'll post it on YouTube later after this class. Okay. Most likely this is going to be a dumb question, right? I mean, no, it's not a dumb question. It's a very standard question. It's not a dumb question. Right, they'll most likely ask you to draw pin 1 and pin 2, which you obviously know is going to be like refracted a little bit, right? And when they ask you to draw pin 1 and pin 2, guys, you cannot draw like, okay, this is pin 1 and this one is pin 2. Cannot. No. The general rule for paper 6 is that it must be at least 5 cm apart. Okay, so let's say if let's say this is pin 1, right, you use a ruler and make sure that it is at least 5 cm apart, and then you draw this pin 2 here. This is a must, guys. You see this a lot in the mark scheme, guys, if you have actually started doing some paper 6 questions. Very, very important, guys. And then whenever I see this question, right, because most likely it's related to the light chapter, right? And if it's the light chapter, most of the time, these kind of questions will say like, oh, this experiment, right, actually is very hard to do in a real life scenario. State what 2 precautions you should do. State 2 precautions you should do to make sure that this experiment is conducted fairly or whatever, right? That's the most standard answer that you see in the mark scheme is always going to be make sure to conduct the experiment in the dark room. Who would have thought of that, right? It's a light experiment. Who would have thought that light pollution would have been a thing, right? So number 1, the most standard answer for the precaution is make sure to conduct the experiment in the dark room. And number 2, make sure to use very thin pencils to trace the light rays. It's a damn standard answer in the mark scheme, and you must know this because once again, it is 3 marks, guys. Okay? Very, 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 very important. What else do I want to highlight? Yeah, make sure you check all these kind of things. They have the units. Sometimes they will juke you unit, no unit, which students, they love to skip the units, right? Then they will not write anything here, then bam, they lose 1 mark. That's done. That's not you. Please don't do that. The measurements here, these are literally 3 marks. Just literally substitute all these things into the formula and you'll get it already. It's literally 3 marks, guys. Unless you're careless or you're panicking or you're dumb, right? Hopefully not the last one. If not, everything else should be quite standard. I do recommend that paper 6 because of the few repeated questions that come out, right? I do recommend that you must at least do like maybe 4 or 5 past year questions from paper 6. Then you can see that actually it's a repeating pattern. Then you'll start to realize that, oh, I know how to do these questions already, guys. For those who are having an exam tomorrow, Charmaine, right? I hope you have been doing some past year papers so that you know what to do. And for those who are having the paper 6 exams next week, for example, the 10B was, is it next week or is it this week? I can't remember. I keep asking, but I keep forgetting.
Next week.
Oh, it's next week. Good. You have time. You actually have time. Please do at least 6 or 7 of the past year papers for paper 6 and read through the mark scheme to see if your thought process hit what they want or not. It's super easy. Literally, if you're scoring anything less than 30, you should be ashamed of yourself because it shows that you have not been putting in any efforts. And if you really have been putting in effort and you cannot score more than 30, please come back and talk to me, because obviously there's something very wrong and I need to, tweak and give some pointers on what's going on. But in general, guys, paper 6 should not be less than 30 for everything, for everything. So yeah, that's gonna be it for today, guys. Do you have any questions that you guys want to clarify, guys? Anyone that has anything they want to ask me before I end the day, guys? Oh yeah, and this one here, please follow the step-by-step. This one here comes out a lot also, and you need to label it correctly, guys. You need to label it correctly, read it slowly, step by step, and just answer it also. But it's only worth 2 marks. But it's very important. It comes out a lot also, this one. Okay. Oh, one more thing I want to say. Guys, don't assume that the scale here is the same as the scales here. A lot of times the student, they'll just like autopilot already. Oh, this one here is like the difference is 0.2, right? This one here, the difference must be 0.2 also, right? But if you actually look through the damn graph, right, you'll notice that it's not the same thing, guys. Don't assume that the scales are the same, and make sure you write your units for each and every one of the things here. Okay, check the tables. Do they have the units? Make sure you get full marks for this graph question, and make sure for this one here, if tomorrow you're lucky, right, Jermaine, you'll get 6 bulletin points. All you need to do is just like answer each and every one of the bulletin points, then you're done already. But if let's say you only see 5 bulletin points, most likely there are 2 hidden marks. The 2 hidden marks, the most common hidden mark is always repeat the experiment 3 times. And the second hidden mark will most likely be either in the 2 key variables or probably 2 marks in the brief description of how you're going to carry out the experiment. Okay, everyone, good luck for your paper 6, guys. Please feel free to ask me any questions if you're uncertain. I'll always try to reply you as soon as I'm done with the other classes. Okay? Okay, good. If you have no questions, that will be it for today. Goodbye, everyone. If you have any questions, once again, you're more than welcome to stay back. Welcome. Goodbye. Why were you late, Joe? 頂你個肺啊！